Let's think of this one just conceptually. I'm not going to have you derive an equation for this one. So we could act this circuit up. Is this a charging circuit or a discharging circuit? Charging. We have a battery. The capacitor is going to charge. Okay, so current flows. We have this I total that's flowing. When it reaches that junction, some of the current can go down each of the branches. If we ignore any resistance that's in the wires with the capacitor branch has a whole lot less resistance than whatever resistor 2 is. But the capacitor and resistor 2, how are they connected? In parallel. So what do they have to have the same? Delta V has to be the same. Delta V for R2 must equal delta V for the capacitor at all points in time. They must be equal. Now, they don't have to be a constant, but they have to be equal. So initially, if the capacitor is uncharged, then the voltage drop across the capacitor at that instant is 0. So the voltage drop across this resistor must be 0. So what can you tell me about the current right there at that instant? Is 0. All the current flows this way initially. But as charge starts accumulating on the plates of this capacitor, its delta V gets bigger. That means this delta V is getting bigger. Current will flow through this branch as well. Junction rule, I total whatever it is at any instant in time has to equal, I1 plus I2 at that instant. So as time goes on, eventually the capacitor is going to reach the maximum voltage it can possibly reach. Is that going to be the battery voltage? No. This resistor's using up some of that, taking a portion of that potential away. So the voltage drop across the capacitor has a maximum value it will reach. It will just not be equal to the EMF of the battery because of that other resistor in there. Whatever maximum voltage the capacitor reaches is the same as the maximum voltage this resistor reaches. Okay. What's happening to the voltage drop across this guy as time goes on? Specifically. It is changing, yes. Is it getting bigger or smaller?
The voltage drop gets smaller.
Voltage drop will get smaller. We look at conservation of energy. Whatever the battery's putting in, this guy's taking some of it out. These guys are taking the rest. Initially, at time equals 0, the voltage drop here was 0 because there was no charge, no current flow through this way. So the voltage drop over here was 0 to begin with. So this guy starts out at that very beginning instant having the full EMF of the battery. As time goes on, this voltage drop here gets bigger, which means this one has to get smaller. At some point, when the capacitor has as much charge as it can hold for this particular circuit, at that point, we'll be at a steady state. The current will no longer change at that point. Okay.
Because of the capacitor, the whole thing just stops.
No, the current won't stop, but the changing of the current will stop. There's a maximum voltage that capacitor can reach. Once the capacitor has reached that maximum voltage, then the current will no longer change in this case. The capacitor can't stop the current though, because there's another branch for current to flow through. Current has the option of coming this way. The only way the capacitor could stop it. Let's say we did something like this. The capacitor in that position, because it's in the main line, there's no branch between it and the battery. Because it's in the main line, the capacitor will eventually reach the maximum voltage of the battery, and it will not allow current to flow over here. But over here, capacitor is not in the main line. So it will reach a maximum voltage. At that point, the current, there will still be current, it just will no longer be changing.
So there will be the same flow of current, but it will just be going through the path of R2.
Correct. Exactly right. So at that point, current will just be going that way. Won't go along that other branch. That's exactly right. So the capacitor stops the current in the branch it is in when it is fully charged.
Won't the total current that, say, the battery is supplying go down? Because
Yeah.
the equivalent resistance at t equals 0 will be lower than at t equals infinity.
Exactly. So as time goes, that total current decreases until it reaches
Steady
a
state.
steady state value.